So everything you're telling me, my conclusion is they're following a procedure. Like they're in their mind, they're trying to remember what to do. And that's very difficult for any of us to do when it's more than like two or three steps. Do you know what I mean? So again, Charlie, you guys have to decide if you want to fix this, you can't be trying to fix it with four-digit dividends. You got to fix it with two-digit dividends. We got to go back to grade three and
Mhm.
say, look, here's the area model, grade three with two-digit area. Look at the number bond. It's exactly the same as that. Look at partial quotients. It's exactly the same as that. You know what I mean? And over the course of the year, and I think this is the fundamental problem in all of math instruction. Even though people talk about teaching for understanding, it's not. The kid's trying to remember the steps for the concrete, they're trying to remember the steps for the pictorial, and they're trying to remember the steps for the abstract. And that defeats the whole purpose. It's like spelling a word. If you have to memorize the order of the letters and you can't sound it out, how many words can you ever learn to spell correctly? You learn to sound it out and you can figure out about 98%. You know what I mean? So that's what you guys have to decide. So for example, if I said this to your fifth graders, this is grade three within 100,
And this is
would
and that's
they all first turn it into multiplication,
hmm
draw the area model, and
hmm
really show me the number bond? So for example, the first step would be to do this.
hmm Got it. Okay.
And then the question is, okay, when you normally use the area model, that's when we typically think of multiplication. It's unnatural. It's not innate to think of area with division, but it is innate, I think, to think you multiply the sides, you get the area. So that's a little bit of a wrinkle. Okay, so we say, okay, what do you know? And I hope they tell me, I know one of the sides, I know the area, I don't know the other side.
hmm
We literally are always asking, like, what does that represent? Not just what do you draw next? Do you know what I mean? Because if you knew what these represented, then I think the drawing is easier. If you know one side and you know the area, well, what's the question then? It's what's the other side? And then the question would be, okay, kids, does anybody know seven times what equals 91? Is that a fact that you should know off the top of your head? And I would want them to say yes or no. What would they say? Is that a fact you're supposed to know off the top of your head? Seven times what is 91?
No.
No. Why not? Like, which facts are you supposed to know off the top of your head?
Well, yeah, well, I guess yes, because if you break it up into 70 and 21,
Yeah, but I didn't ask that. I said, are you supposed to know it off the top of your head from memory? No.
They know because we haven't gone beyond the 7 times 10 tables.
Exactly. That's the point. Kids should not be going, oh, am I supposed to know this one? I'm not supposed to know this one. Oh, I feel bad. I don't know this. No. You know what you're supposed to know off the top of your head from memory? The times tables. And that means going up to 7 times 10. So when a kid sees this, they should right away going, oh, it's not the times tables. That tells me to break it apart. It's too big. And then the question is, okay, what do you break it into? And that's where I use my times tables. Now, of all the times tables, you don't just pick a random one. Where do you start? What's your go-to every time? It's 10.
Right.
And the question to the kids is, why 10? Why isn't it 7 times 7 is 49? I mean, most people know that fact, but why do we go to 10 first, always?
because we said it's a friendlier number to work with, and that, we have a 0 in the ones place, and that's always,
Yeah, and you don't even have to get that complicated. That's what I'm trying to get to simplify it. Do I call you Zippy?
Yes. Thank
Okay,
you.
I don't want
Yes.
to.
Yeah.
Okay, you know why we go to 70? Because we're a base 10 number system. And that's going to be important that they understand the whole number system revolves around base 10. And that's going to be crucial when we get to decimals. That's going to be the link to decimals. Turns out decimals are just fractions. It's a different way to write a fraction. But we don't do all the fractions when we do decimals. Guess which fractions we do? Tenths, hundredths, thousands. We only do the decimal fractions. So because we're base 10 number system, we keep doing things around the number 10. And that's why it's smart to go to 70. And here's the second reason it's smart. Is it easy to subtract 70 from 91? Yep.
Yes.
And you know why, kids? Because it's a base 10 number system. So whenever you do things in tens, it makes everything else easier. And that's why we did it. And then we go to here. And then the question is 21 in the times tables? Then
Yes.
that's why if you know your times tables, it makes it so much easier. And that's why we do it like this. And over time, you hope when I see 91, I'm thinking 70. Oh, 70, 21. So I hope they get this. Like you made it sound like they would be comfortable with that because it's area model, which is great. So the next step,
They do the 2 digits. I think that they could do the 2 digits.
Mhm.
so you'd want this so good because here's what we're doing with 2 digits. We're building that link that you said they have trouble when you get to the number bond. Like, oh, they're more comfortable with this, but then when I get to the number bond, it kind of starts to fall apart. That's why we got to do it when it's comfortable, 2 digit. So now here's the next step. Ready? We rewrite it. Think back, kids. What did you do to the 91? You broke it into how many parts? 2.
Good. Mhm.
Guess what we're going to do to the 91? We're going to break it into 2 parts. 2 different parts or 2 of the same parts? Exactly the same. 70, 21. It's literally the exact same thinking. 91 is 70, 21. 91 is 70, 21. Which is easier to draw? 91, 70, 21, or 91, 70, 21? This is just like a shortcut way of drawing what we already did. That's all we're doing. We need kids to see you're not thinking differently. You are writing differently. You're notating, you're changing the notation from an area model to a number bond. Now, is an area model a picture of what I'm thinking? Yep. Is this symbol also a picture of what I'm thinking? It is. So over time, we go from more complicated pictures to less complicated pictures. That's it. And then what did we do up here? We went 7 times what is 70? What could you do down here? You could go 7 times what is 70? Or you could go 70 divided by 7. That's exactly what we did up here. We did 70 divided by 7 is 10. Here I'm writing it 70 divided by 7 is 10. What did we do up here next? We did 21 divided by 7 is 3. What do we do down here? 21 divided by 7 is 3. What did we do to get the final answer up here? We added the 10 and the 3 to get 13. And what do we do down here? We add the 10 and the 3 to get 13. So we really need in grade 3 and 4 that they've already connected the area model and number bonds when the numbers are still small.